Hey guys, so this is the second example of the presentation that you're required to present in class. Mm, So the paper that I'm presenting is Object Manipulation in Virtual Reality under Increasing Levels of Translation Gain. The first two authors have contributed equally to the project. The paper specified that. They were all from University of Glasgow, and this was published in IEEE. So um, in virtual world, um, you you are transported to a new world basically, and you have the freedom to look around. With today's technology, you have the ability to interact with the virtual objects, move around, and that movement is really important. So there have been different techniques introduced, which allows you to move around in virtual world. Why these techniques are important? Because you don't always have enough space. So let's say if you work in a lab like mine, you have ample amount of space to move around. But if there wasn't such, there's usually not so much space in regular household. In that case, these techniques are really important. And techniques like that can go as simple as using joysticks to move around, like you do in PlayStation or Xbox. Then there are more complicated techniques, like redirected walking or impossible spaces, which directs the user to stay in the constrained space. Um, and then there's similar to that, there's translation gain, where the movements are amplified or accelerated by map changing, or multiplying the gain, or movement in x and y axis as opposed to the z axis. Um, so that means that if you jump, you jump the same amount in real world and virtual world. But if you walk, so let's say what you walk 1 meter in real world, that means that 2 meters in 2x gain virtual world, 3 meters in 3x gain virtual world, and 50 meters in 50x gain virtual world. There have been um, studies, and this technology has been um, here for quite a while now. But the there there's been no study about interacting in a gain environment. So the objective of this paper is to understand the extent of comfortable translation gain without affecting users' ability to interact with virtual objects. So the experiment was designed in a way where um, they have been given an array of cubes, and they are placed on either a wall or a table. The person has to pick up the highlighted cube from the rack being the wall or table, turn around, and walk to the opposite rack, wall, or table while avoiding the virtual obstacles. They have to place the cube in the designated place in the rack. So this is a video. As you can see on the left, the blue is the highlighted one. There's the obstacle they have to walk around, or on the right side you have the zigzag to reach the other side and place the cube. As you can see on the right side, there are no obstacle before they pick up a cube. When they turn around, the obstacle comes up. The experiment is designed in such a way. This that was 1x gain. In 3x gain, as you can see, the person is moving the same amount in real world, but in virtual world the room is bigger, the obstacles are much bigger, and the target is much farther away. But and you can see when he bends down to pick up the objects, you notice a lot of instability. That's important. We'll see why later. So they had 20 healthy participants, 19 females, 11 female, 9 male, age between ages of 20 and 35. They were paid £20 after 2 sessions. They made it. They divided the experiment in 2 sessions for each participants, because the participants have to move around, and they might get tired and maybe want to leave the experiment in between, and you don't want that. So the experimenters divided in such a way that each participant has two orientations, that's wall and table, and three gain levels random and two gain levels on the second day. So in this way, the gain levels that they chose were 1x gain, that is no gain at all, 1.5x gain, 1.75 gain, 2x gain, and 3x gain. The measures that they took and the task measures, quantitative measures, were time, the trial duration, and reaching time. So trial duration was the total time to complete the task, and reaching time is once they reach the wall or table, the amount of time they took to select or pick up or drop the cube. Movement is walking velocity and tortuosity. Tortuosity is the head swaying from left to right that measures dizziness or how unstable they feel. Reaching precision, target selection correctness, target selection accuracy. So target selection correctness is the correct cube that they selected and how precisely did they select it. Subjective responses were nausea, which was measured using simulator sickness questionnaire, workload using NASA TLX, and they had some custom questions. So, like my movement felt unusual, I felt unstable while walking, I felt unstable while reaching. These three were measured using 7-point Likert scale. The results that they found were for the time they saw that increase in mean trial duration with increase in gain. This was, they say, maybe accounted for um, because of the side effect of reaching um, reaching from one spot to another. You have to travel more when there is a gain. For example, you can see if let's say the object is 1.75 meters away in real world and 1.75 meters away in virtual world, arm length is zero point 0.5 meters, then the person has to walk 1.25 meters in real world and walk 1.25 meters in virtual world. With 1x, this is simple enough. But 3x can we notice something interesting. The object is again in real world 1.75 meters away and 5.25 meters away in virtual world, since 3x gain. Arm length again stays the same, 0.5 meters. So the 3x gain, the person has to walk 4.75 meters in virtual world to reach with an arm length of 0.5 meters to reach a distance of 5.25 meters. So the person has to walk 1.58 meters in real world, while in 1x game, person walked 1.25 meters in real world. So there is a significant increase in virtual world. So that's 26% increase in effective distance for 3x gain compared to 1x gain. Oh, yeah, you can notice that the speed decreases as the gain increases. Um, for movement, increase in virtual world velocity, which is obvious because you see you the person is moving a greater distance in virtual world in the same amount of time, so obviously the velocity is increases. But they also notice decrease in world velocity, that's 25% decrease. This is because of unconscious gain compensation. You have the person is used to a some set speed that they walk with, using some amount set amount of energy or using some set amount of muscles, right? That was completely changed because of the gain. So they unconsciously slow themselves down to slow themselves in virtual world. Increase in unsteady movements. This is unclear. This may be because of actual instability or because of increase in step count, since you have to walk further as yeah, the gain is more. Um, in the graph, you can see, imagine there's a table here or wall here. So you have to select the cubes at this points, and these are pretty precise since this is 1x gain. But in 3x gain, you see this blur. There's a buffer. This is because when they lean forward to select a cube from the table, they're effectively moving in XY direction, and that's also gives a gain. So the precision is not well. Same in case of wall, when they bend down, they're moving the headset forward. For reaching precision, they notice more than 90% accuracy from 1 to 2x gain. And in the graph, you can see they prefer. In the graph, blue to red is the range of the depth that um, they pressed for the cube. So it's interesting to note that for cube, for the table, they pressed more, while on the wall they were hesitant to press inside. For simulator sickness questionnaire, they noticed from 1x to 2x gain, it was less than 18.8, a threshold which was suggested by Kennedy et al. Um, for mean score for 3x gain is approximately 21, which is just past the threshold. NASA TLX, again, there was significant difference between this whole set and 3x. For interview responses, 11 participants said they had problematic, they found bending down problematic. Three of them adapted to crouchings because they were pretty smart, I guess. Too smart, I guess. They they bend down, crouch instead of bending down, so that the headset doesn't move forward. Inconsistent perception of space and gain, and high gain affected stability. Discussion 3x gain repeatedly showed less accurate measures. Accuracy is more on 2x. 2x is usable. Possibly it can go higher, but don't know the exact point where it gets problematic between 2x and 3x gain. Simulator score hard cap on 2x. Perception of movement in line with research suggestion of 1.6 gain, where they start noticing weird movement after 1.6 gain. Instability was significant at 2x. So these are the values that they recommended. And for in general scenario, 1.5x gain, traditional translation gain is the best one. Maybe if there's less amount of objects and limited bending and reaching tasks, then 1.75 gain. And training and practice may reduce the negative effects. For future work, they want to examine different tasks with different gains, since the task was pretty similar, but if they had to interact more or less, then it might vary, or depending on different tasks, like carry or maybe draw or something like that. Increase in field of view of consumer VR may change this. For example, there's a headset with 180-degree field of view that might be better in some sense. Virtual environment with closed obstacles and limited movement freedom might result in different recommended levels. Deciding which point on user's body should be checked for movement to apply translation gain, since this one is just with headset, um, there might be some problems. Since there are problems while bending down, so they might have to redo a research with, let's say, waist would be a good focal point for translation gain measure. And gradually increase means this might be like for training and practice, they can always increase to a higher gain levels. If you have any questions, post them on the Piazza post that I'm going to put up. Thank you.